I'll start out by saying this project really should be presented by Tabitha Brown, but she's back in Pullman writing a dissertation with the hopes of getting done. So part of Tabitha's, she was an NSPIRE graduate fellow. Part of that was to do an internship, and she chose to intern with Stockholm Environmental Institute to try and wrap her mind around this question of potentially trading carbon and nitrogen. And they're a group that's done quite a bit of assessment on that. And so the project that we ended up settling on was this idea of road testing some nitrous oxide emissions protocols relevant to Pacific Northwest wheat production and some of the nitrogen management decisions that could be made. And so this one fits in quite a few places. Transdisciplinary framework, nitrogen monitoring, some touch on the dynamic AEZs, quite a bit of dependence on the long-term experiments for some of the underlying data, and of course potentially developing some extension products. In terms of where it fits on the outputs, really comes in on the nitrogen budgets, recommended climate-friendly strategies, assessment of socioeconomic capacity to support change, and we will have a couple of different tools that come out of it. And we're focusing on increasing nitrogen use, nitrogen efficiency, and increasing grower knowledge. Okay, so the first thing that Tabitha did is she actually went and did some searching to see, what existing protocols are out there that actually treat nitrous oxide as a potential crediting mechanism. And there were 5 that she found globally. 3 of those are relevant to our region in the sense that they don't exclude us. And I think that's the really important factor, is most of these have been designed and developed for other systems. This Canadian one basically only applies in Alberta. This Climate Action Reserve one only applies to the north central region of the US. These other 3, even though they weren't designed for here, have not been excluded for use from here, but they may be after we're done with our project. A little bit of what these look like, and so this is the different protocols, the 3 different gases that they look at, kind of the baseline activity and the changed activity, direct emissions from fertilizer application, indirect emissions from fertilizer application, emissions from fossil fuel combustion on site as a result of nitrogen management, and emissions from fertilizer production and distribution. And she basically just went through and looked at these protocols and said, yes or no, do they address this in the context of the protocol? And you can kind of see that there really isn't a whole lot of the potential options that these protocols address. This ACR1 certainly addresses the most of them. But what's really interesting is when she did this assessment, she looked at 3 of these protocols, ran them all, and they basically came out largely the same. So even including these other factors on this first one doesn't really change the result that much. So what did she actually look at? So we spent some time discussing, what are some scenarios, some nitrogen management scenarios that producers in the region realistically could consider doing. Then we could ask the question of what would the impact be on nitrous oxide emissions, and then ask the question of, what incentive could be provided to induce this change from these protocols. And so using data from the Cook Agronomy Farm, we ran 3 scenarios. They're basically shifting from hard red winter wheat to soft white winter wheat, hard red spring wheat to soft white spring wheat, and variable rate nitrogen applications, so precision ag. A couple of really interesting or important points here. We use the Cook Farm's historical nitrogen management strategy in order to run these numbers. And so you can't just say it's completely relevant to every managed farm in the region that's doing one of these 3 things. And so, but the question is, what if we induced a shift from where we're currently at to the new place? And you can see in some cases, 85, 113, and between 25 and 41 kilograms per hectare of reduced nitrogen input on these scenarios. So that's a pretty significant amount of potential change. But what does it actually mean? So here's where we get into some of the messiness of these protocols. In the case of our region, there's only one tier, which is Tier 1, that's eligible in our region, and that's because it just basically uses the default IPCC indexed nitrogen or nitrous oxide emissions rate. We don't have in any of these protocols relevant to our region a Tier 2 number, which is a data-driven number, and that's one of the outcomes that should come from REACH. The other thing is there is a Tier 3, which is a model simulated output, and we potentially can provide that too. But what Tabitha did here is she looked and she just ran these scenarios for Tier 1, which is using the IPCC index number, and then she ran it for Tier 2 based on some existing regional data that indicates that, you know, our nitrous oxide in the emissions in this region may not be nearly as bad as the IPCC estimates are. And so basically what you can see is there is a fairly substantial potential reduction of nitrous oxide emissions from Tier 1 for each of these three management strategies that we could change. Secondly, if we go to that Tier 2 number and use that lower emissions that has a little bit more data specific to our region, what you see is we don't get nearly the reduction. And part of that is we don't produce nearly as much nitrous oxide if we're using that Tier 2 number. Therefore, the change doesn't induce that much of a reduction. And another thing is all of these protocols are based on the application of nitrogen, not actually on any kind of more sophisticated approach to actually predicting nitrous oxide evolution, which is why Tier 3 goes to the model simulation, which should be able to put that together. And we know from a couple of studies that nitrogen application rate is not a very good indicator. It's not linear with nitrous oxide emissions. Therefore, what that means is coming back here and using either Tier 1 or Tier 2 is probably going to be wrong. The last thing I wanted to show is we then said, okay, what if we did these reductions, captured some value for that nitrous oxide reduction through some kind of carbon credit, and then said, what would it mean in totality? And we ran $5, $10, and $50 per ton of per metric ton of CO2 equivalent kind of numbers, and then said, you know, how many hectares in the region are managed that way? What's the total dollar number? And then just for kind of simplify this, I took one of those, the moderate $10 per ton of CO2, which is actually a pretty good price right now, and kind of broke it out on a per hectare basis using this direct emissions factor from IPCC of 1% or the regional emissions factor that Tabitha ran of 0.2%. And you can kind of see, and this is on a hectare basis, not on an acre basis, there just is not a lot of financial incentive that could come from crediting nitrous oxide emissions reductions, down from 61 cents an acre on variable rate nitrogen up to best case scenario still under $6 per hectare on the inducement. And so what that kind of shows you is this potential to incentivize and induce change on the basis of a carbon credit for nitrous oxide emissions is just not very strong. Now, if you couple that with the fact that there are reductions in the cost of nitrogen because you're applying less nitrogen overall, and some questions on the market side in terms of output and the value of that output, the picture gets a lot better. And so that's not to say that there's no interest in this potentially being a relevant scenario. It's just that this inducement itself is probably not very significant. So kind of the findings, there's a limited number of N2O protocols available in the region. Using the Tier 1 factor could significantly overestimate both N2O emissions and potential N2O reductions in the region. Using N-rate reductions as a constant emissions factor to estimate N2O reductions is not likely to be accurate. And stacking of offset credit revenue along with other incentive-based approaches is likely to be required to realize N2O reductions in the region.